We're going to use the same techniques we use on the tangent and cotangent graphs in order to graph the secant and cosecant graphs. So here's the graph of cosine. We're interested in the secant function, and of course secant theta is 1 over cosine theta. In other words, the secant function is the reciprocal of the cosine function. And that's the fact that we need in order to graph this. So remember, when we take the reciprocal of a function, the zeros become vertical asymptotes and the vertical asymptotes become 0. Now in this case there are no vertical asymptotes up here, so we only need to focus on the zeros becoming vertical asymptotes. So we got one at negative pi over 2, we got one at pi over 2, and we got one at 3 pi over 2. Now I'm going to do something that's very specific to graphing the secant and cosecant functions, which is I'm actually going to plot the underlying cosine function on my graph. I'm going to do it as a dotted line because this is not the graph of the function that we are actually interested in, but it's related to it. And it'll help us graph this. This is really sloppy right there. I'm going to fix that. It's a little bit better. Okay, so what are we going to do? Well, the reciprocal of a function, right? You flip the fraction over. Let's think about the value right there, or the value right here. This is happening at a value of 1, and the reciprocal of 1 is just 1. And so this point right here, the peak of the cosine function, is going to be a fixed point under this taking reciprocal process. Same thing with negative 1 down here. The reciprocal of negative 1, 1 over negative 1, is still negative 1. So these points help to anchor our graph. And so that's part of why this thing gets sketched underneath. And then the question is, well, what's going to happen? You can see that as we move to the left and to the right from this point, the function approaches 0. If you take the reciprocal of that, it says that the function of the reciprocal is approaching infinity. So we're going to have vertical two positive moving things moving towards those vertical asymptotes. Down here, same thing but negative. And so you can see that there's this alternating up, down, and this side over here will be another up pattern. The period of this function is 2 pi because the underlying function, the cosine function, also has a period of 2 pi, and you can actually see it right here. You can see it repeating. So here's 0, and actually the 2 pi point right here happens like that. And so this helps us to see how we can get the graph of the secant function out of the graph of the cosine function using the ideas about reciprocals. And lastly, we have the cosecant function. Now you should be able to actually do this on your own without my guidance, but we're going to go ahead and go through this anyway. So the cosecant function is the reciprocal of the sine function. And so we're going to take a look at the graph. And remember, zeros become vertical asymptotes. So there's a 0 here, at negative pi, at 0, at pi, and at 2 pi. Just as with the secant function, we're going to graph this underlying sine curve. These points right here, the plus and minus 1, are fixed points in this transformation. And we'll have the same shape as before, except just shifted over. Now the reason this has the same shape as before is because there's actually a relationship between the sine function and the cosine function. These are known as the Cofunction Identities, which basically say that this is a shift and a reflection of it. And so these two shapes are actually the same basic shape, just shifted over from each other. And so this is the graph of the cosecant function.